Welcome back. Last time we decided when added autonomy was justified. Now we move from whether to build to which engine belongs in each job. Acme scored 3 out of 3 because the work had judgment, rule churn, and messy customer input. That score justifies a pilot. The useful threshold was 2 or more. When Acme crosses it, an agent is recommended, but the design still needs limits. 0 still matters. If the work has no real uncertainty, stay deterministic and keep ordinary Python branches in control. That prior verdict sets up today. Once the pilot is justified, the next question is which model each role deserves. Now the course moves from yes or no judgment into design choices. This section matters because bad choices become expensive after users rely on them. Part 4 begins the design group. The work shifts from deciding whether an agent fits to shaping how each role should operate. Today focuses on model selection. We will decide when GPT-5 Mini is enough and when GPT-5 is worth paying for. Next, the agent stops guessing from text alone. Part 5 adds typed data tools, so support answers can use orders and shipments. The rest of design adds prompt structure and loop boundaries. Those choices keep the same Acme system controlled as it grows. A small build does not prove the choice is good. The next screen ties spin to correctness before we optimize anything. Here is the problem you can picture. A cheap answer that mishandles a refund still costs the business. Price follows quality. The OpenAI guide says to start with the biggest model first. That finds the quality ceiling before you try to save money. After that, downshift where evals hold. The eval set is the proof that the cheaper model preserved the behavior. The trade-off has 3 knobs: capability, cost, and confidence. Confidence comes from evals, not from liking a cheaper invoice. Think of a support team with different desks. Simple sorting and serious judgment should not sit at the same desk. Triage and classification go to GPT-5 Mini. The job is cheap, fast, and deterministic because it returns 1 label. Tool calls also start on GPT-5 Mini. The exception is a risky tool where the decision around the call needs more capability. Refund decisions go to GPT-5. The source calls this irreversible, so the capable model is worth the extra cost. Lock this in. Every role declares a model, then the eval set defends that choice. Defaults are not a design plan. Lowering the bill safely needs a path, not a hunch. The sequence starts broad and narrows after evidence appears. Guessing is the failure mode. If you begin with the small model, you do not know whether failures are prompts or capability. The fix is to measure with evals. Use labeled support messages so the model choice is judged against expected behavior. Capability gaps show up as wrong labels or overconfident decisions. When that happens, do not keep polishing the prompt forever. When the evals hold, downshift. That is how you save money without silently lowering the quality of Acme support. Now we make the design runnable. The point is to see the choice in Python, not only as a diagram. The file is lesson_04_model_selection.py. It imports agent, model settings, and runner, then loads environment values with load_dotenv. Acme Triage is the small deterministic classifier. It owns the first routing question before any expensive judgment happens. Acme Refund Decider is separate. It uses the bigger model for approve, deny, or escalate decisions. EVAL_T, and run_eval make the example measurable. For labeled messages tell you whether the triage role is behaving. Think of this code as a sorting clerk. The triage agent uses model equals GPT-5 mini because it only classifies a customer message as refund, shipping, product, or other. Model settings, temperature equals 0.0, keeps that answer steady, and the instruction says to reply with just the label. That makes the output easy to check in an eval. Transcript for slide 7-1. Transcript for slide 7-2. Transcript for slide 7-3. Transcript for slide 7-4. Transcript for slide 7, all items. The second code block is the senior desk. Acme Refund Decider uses model equals GPT-5 because a refund decision can approve, deny, or escalate money-related work. The important design move is separation. The cheap model sorts the request, and the capable model handles the consequential call. Transcript for slide 8-1. Transcript for slide 8-2. Transcript for slide 8-3. Transcript for slide 8, all items. A price comparison needs labeled examples beside it. Without them, you cannot tell whether the cheaper role still behaves. Eval_tickets starts with a refund request. I want my money back for order 8821. The expected label is refund. The second customer asks, where is order 8822? That expected label is shipping, so status questions stay distinct from refunds. The product example asks whether Watch Pro 1 comes in silver. That expected label is product, not shipping or refund. The fourth message is my cat is hungry. The expected label is other, which protects the workflow from off-topic inputs. Think of run_eval as a tiny scoreboard. For each message, runner.run_sync, tree of, message, gets the model output, then final_output.strip.lower, normalizes it. The check uses got starts with expected, so a correct label still passes if the model adds a little extra text. Finally, accuracy prints correct over the length of EVAL_T, Transcript for slide 10-1. Transcript for slide 10-2. Transcript for slide 10-3. Transcript for slide 10-4. Transcript for slide 10, all items. Now we check the promise outside the editor. A working run turns the design from theory into a result you can compare. Run Python lesson _04 model selection.py. The first line should say the tree of eval is running with GPT-5 mini. The expected labels are refund, shipping, product, and other. In this run, the got values match all four. Accuracy prints 4 out of 4. If expected and got disagree, keep the capable model or tighten the instructions before downshifting. Here is the mistake that wastes the most debugging time. The symptom looks like a bad instruction, but the root is usually a mismatch. Picking the cheapest model first creates false savings. You spend weeks debugging quality issues that are actually capability gaps. The wrong diagnosis is prompt blame. If the role needs more capability, wording changes will not reliably fix the behavior. The correct fix is start big, then downshift. Let the eval set prove the smaller model before you depend on it. The second mistake is quieter. A lower bill can look successful until you ask how many correct answers it preserved. No eval set means cost is meaningless. You know the price, but you do not know whether Acme still answers correctly. Zero labels means zero defense. You cannot justify a cheaper model from vibes, screenshots, or one lucky customer message. Even 20 labeled tickets are infinitely better than zero. Start small, but write down expected answers before comparing cost. The lesson closes with a reusable habit. From here on, the chosen engine stays visible and testable. Every later agent declares model equals. That makes the runtime choice visible instead of hiding it in a default. Every model choice needs evals. The cheaper role has to prove it preserves the expected support behavior. Part 5 changes the next constraint. The agent will need typed data tools instead of answering from text alone. Next, we wire lookup_order, lookup_customer, track_shipment, and search_KB with that function_tool and Pydantic, so Acme can use real data.